Good morning. Good morning to all.
Good morning, sir.
What was the last thing we covered in the previous class?
So you had given some problems from the booklet to do.
On which topic?
There's basically circuits only.
Sir, cells you were
So we had done last question on internal resistance, which was connected, many were connected in parallel, and then we are told to find current through 125 volts.
We were solving problems based on Kirchhoff's law, nodal analysis, and equivalent batteries, right?
yes, sir.
One important point I want to make regarding maximum power transfer theorem. This is say 100 volts. 20 ohms, 10 ohms are. Now, actually, I was giving you that day this particular example, but I went wrong with the values. But bottom line, what I want to explain is this. If you ask me, find R for which power dissipated through R is maximum. Power dissipated through itself should be maximum. So what will I write? Power is equal to I square R. What will I be? 100 divided by R plus 30 whole square R. Do dP by dr is equal to 0. You will get R is equal to 30 ohms. You will get that answer. You don't need to worry about the simplification. Right? And why am I getting 30? Remember, maximum power transfer theorem. This resistance should be equal to the total internal resistance of the circuit. 20 and 10 are considered to be the internal resistance, sum total put together. So you will get the answer as 30. You can simplify and see, no big deal. But suppose I change the terminology and ask, find R for which power dissipated through 20 ohm resistance is maximum. I want the power dissipated through 20 to be maximum. You have fixed the resistance. So for power to be dissipated to be maximum, that implies I should be maximum. For I to be maximum, R should be 0. Don't tell me you will apply maximum power transfer theorem here. Maximum power transfer theorem applies when you are finding out the maximum power through itself. When you want the maximum power through something else, don't apply maximum power transfer theorem. Don't tell me maximum power through this will be when 20 is equal to R plus 10. It will not be. Maximum power through this, when you have fixed up R, current should be maximum. Current is maximum means R should be 0. See the logic carefully. They are two different systems. You are asking me maximum power. So why don't you apply the same logic in this? I cannot put R equal to 0. If I put R equal to 0, power will become 0. It will become a minima, not a maximum. Right? When I want maximum power through this, that resistance should be equal to the total internal resistance of the circuit. But that should be the variable which you are finding. You give me this as the variable and I ask for maximum power through another known resistor, then I square R. What is I square? 20. I should write this as I square into 20. This is fixed. R is not a variable anymore. You are playing with I. I should be maximum. When will current be maximum? When R is 0. The other class, I couldn't put it this way. I actually wanted you people to find it out on your own. And I gave values which were not appropriate. Hence, I'm representing it this way. Observe this carefully and make a note of it.
When we had to maximize power through R, so at that time, why didn't we take R as 0?
Take R as 0, what will you get? Maximum power milega?
No.
0 milega. That
Understood.
means R is non-zero value. You are given certain resistance. Other than 0, find out the value of the resistance for which maximum power through itself.
Sir,
Huh.
last class we had done a question where you asked find R for which power dissipated through 30 ohm is max. In that,
R should be 0. Change that if we have committed a mistake there. Make a note of this. If this was 30, was this 30?
so that was 25. Then the one which is then that was small r, and then the capital R was 30. So it should be 0, right?
Repeat the question.
Instead of 20 ohm, it was 25 ohm.
$25 ohm.
25
Small
ohm.
R.
Then
That was
30 ohm.
This was
30.
ohm.
30.
And that's small r. And 100
What
ohm.
did I ask her?
Small R.
Yeah.
Then small r should, and maximum power through?
30.
30 ohm.
Maximum power through this means current should be 0. For power through 30 ohm to be maximum, small r should be 0. If power through this should be maximum, R is fixed,
Yes, sir.
right? So I should be maximum. I is maximum when small r is 0. Make the correction in what we have done in the last class if you have taken any other value.
So, but when we found it dV by dr, you are getting smaller as 5 ohm.
No, so you're getting 0.
We're getting 0 now.
Yes, sir,
Zero.
will be 0 now.
We committed a mistake there. That's why I'm rectifying it. You will get 0. Tell me when I can rub the board.
Done, sir.
Done, sir.
Sir,
Slide.
so, second last question which we had done, in which there was those resistance, we had done it using nodal analysis,
Right.
where we got the relation as, so that we got that 4i1 plus 4i2 will be that potential difference. We found the current.
Okay.
So, sir, there 4i1 plus 4i2 can't be equated to i1 because the current to that also was i1, right?
It is the same thing. Direction dekh lo, potential difference dekh. Current through that will be I1. See the potential difference. Is it the same?
Yes, sir.
And the direction of current.
We found it I1 only, but we equated to the potential difference upon resistance.
That will be I1 only. Potential difference upon resistance.
So
If
basically
it is not
substituted
giving you
I1.
I1, then it's not I1. It should be giving I1. Potential difference upon resistance. Is it giving you I1 value?
Yes, sir.
तो फिर दिक्कत क्या है?
So basically substituted I1 in all, right?
But you had to calculate V no yaar.
Yes, sir. I1 was in terms of V only.
Ah. Now listen. This is transition into the experimental part of current electricity. What is an ammeter? It measures current. Ammeter measures current. Measures current. Right? Ammeter is represented by this symbol. It is always connected in series. It is always connected in series. Connected in series. Why should it be connected in series? I am measuring current. If the same current passes through the ammeter, I will be able to measure it. Right? Ideal ammeter should have resistance 0. So you have an ammeter placed in series to this with an internal resistance of the battery 100 volts, 10 ohms, 40 ohms. Ideal ammeter will measure the current 100 divided by 40 plus 10, 2 amps. Non-ideal ammeter will have certain value of resistance, say 5 ohms. This will be 40 ohms. You have a resistance this way. This is 1000 volts. What will I be measured as? 100 divided by 40 plus 10 plus 5. 100 divided by 55 amperes. So, when you have an ammeter with some resistance placed in the circuit, you will be measuring a wrong value of the current. Hence, an ideal ammeter's resistance should be 0. Is the logic clear to you?
Yes, sir.
You change the current and then you measure the current. Doesn't make sense. Unless and until you do the rectification, you know the internal resistance of the ammeter. After calculating current, subtract that and find the value of current without the ammeter would be a different case. Take it down till here.
Done, sir.
Done, sir.
Sir, 1 second.
Now listen. How do I convert conversion of a galvanometer into an ammeter? What is a galvanometer? It is an equipment which just shows deflection when current passes. Equipment which just shows deflection when current passes. But galvanometer is very sensitive. It measures up to micro and nano amperes. You send 1 ampere of current, the needle will hit and break in 1 second. So even 1 ampere of current I cannot send through a galvanometer. First precaution I have to take is galvanometer is very sensitive. Very sensitive. Very less amount of current should pass through the galvanometer. So how do I use as a tabletop ammeter? If you have a galvanometer this way, place a shunt resistance in parallel to it of a very low value. So that if I current is coming into this, IG is going into this, IS is coming into it. I will be IG plus IS. Shunt resistance is of a very low value. SE is very low. S is of a very low value. What will happen? IS will be very large. Larger proportion of current will be passing through the shunt resistance. Lesser current passes through the galvanometer. Right? IS will be very large. IG will be very small. So IG is very less. Very small a value. IG will be very small a value. So firstly, you have safeguarded your galvanometer. First point, is it clear to all?
Yes.
Yes, sir.
Now next point, remember, if two resistances are in parallel, equivalent resistance will be lesser than the least value. क्या बोला मैंने? If two resistances are in parallel, equivalent resistance will be lesser than the least value. 4 and 2 are in parallel. What is the equivalent resistance?
4/3.
It's lesser than 2.
Yes, sir.
Yes, sir.
5 and 10 are in parallel. Equivalent resistance will be lesser than 5.
Yes, sir.
So effectively, when you have two resistances in parallel, the equivalent resistance will be lesser than S. Right? R equivalent will be G into S divided by G plus S, which will be lesser than S. S is much lesser than G. This resistance is much lesser than this. That's why maximum current is passing through it. Now S is much lesser than G and R equivalent is lesser than S. So effectively R equivalent is a very low value. Close to ideal ammeter. Ideal ammeter's resistance should be 0. You are effectively brought down the resistance of this. R equivalent has come down, it will be much lesser than G because S is much lesser than G and R equivalent is lesser than S. So R equivalent will be much lesser than the galvanometer. So you have come close to the ideal ammeter situation. These are the two precautions. Now effectively job should be done. I should measure the current I. How do I measure the current I? My equipment can measure only IG. IG will be S divided by G plus S into I. I will be G plus S by S into IG. I will be G plus S by S into IG. You wanted to measure this current? IG is measured by your galvanometer. Now, do you remember the formula as to how to split the current between the two? I want current in this branch. Resistance in the opposite branch divided by sum of both the resistors into the incoming current.
Yes.
Now I can measure the current. IG will be in microamperes. I will be in amperes. So generally they ask the question in the reverse. If I should construct an ammeter which measures up to 10 amperes, what should be the shunt resistance? If the galvanometer can measure only 1/100th of an ampere. Galvanometer में 100 ampere डालो, 10 amperes, G is known. You are asked to calculate S.
Sir.
How do you construct an ammeter from a galvanometer? By placing a shunt resistance of a very low value parallel to it. The process is called shunting. Name of the resistance is shunt resistance. S-H-U-N-T. S is called S-H-U-N-T. Shunt.
So what if G is 0?
G cannot be 0 यार. Galvanometer.
Ideal.
Ideal galvanometer नहीं मिलेगा, इसीलिए तो कंस्ट्रक्शन कर रहे हैं. G तो 0 होगा ही.
Obviously. And so IS is
0
very
होगा ना, तो IG will be almost infinity, and that will destroy the galvanometer immediately.
and so IS is very large. So won't it burn the shunt resistance?
Shunt resistance will be constructed in such a way so that it can. IG is very. क्या बोल रहे हो?
If IS is very large, so heat will be
S
much
is
more, right?
low, yaar. S is low, so heat will be I square. Yes. So S will take care of it.
Okay.
Done, sir.
Can I rub the board?
Yes, sir.
Conversion of galvanometer into a voltmeter. First of all, what is a voltmeter? First of all, what is a voltmeter? Voltmeter will measure potential difference across any component. This is a resistance. You have a battery. This is R. This is capital R. I want to measure the potential difference across R. AB. Potential difference across AB is I into R. Ideal voltmeter should not take any current from the circuit, should not disturb the circuit. So ideal voltmeter resistance should be infinity. It should not take any current from the circuit. It should maintain the same current in the circuit so that the resistance and its circuit is not disturbed, just for the measurement of potential difference. So you should have an ideal voltmeter with resistance infinity so that you are able to measure the current. When resistance is infinity, no current passes through the voltmeter. Whole of the current goes into the same circuit. So effectively, you have not changed anything, right? So an ideal voltmeter, firstly, voltmeter is always connected in parallel. Voltmeter is always connected in parallel. And ideal voltmeter should be of infinite resistance. Now, how do you construct a voltmeter from a galvanometer? Take a galvanometer and place a resistance of very high value. Place a resistance of very high value. This completed the voltmeter. So what is R equivalent here? G plus R. G itself is generally high value to protect itself. You are placing another very high value resistance in series. Effective resistance is G plus R. This will be very large. This will be very large. Right? Ig into G plus R will be your reading of the potential difference. Current passing is Ig. So this circle is this. Inside you have got galvanometer and the resistance. So whatever current passes through this, Ig into G plus R is the potential difference here. It should be the potential difference across AB. Once the resistance is very large, you are meeting the requirements of an ideal voltmeter. Is it ever possible that you take no current? Here you are making resistance large. You haven't made it infinity. Can you ever measure the potential difference across this without taking any current from it? Yes, we will right now.
Done, sir.
Done.
This equipment is called potentiometer. Potentiometer. Very frankly speaking, you should do this experiment to get a complete feel of it. In my 12th board examination, CBSE, I got this in my board exam. Right? I'll tell you something funny at the end of this. A potentiometer is basically a wire. Today you have got good quality wire, so you take 3 to 4 turns. Our times it was a copper wire. So such a long wire working is difficult. So on a 1 meter wooden bridge, they turn the wire 10 times. They take 1 meter wooden bridge and they turn the wire. Right? You will get 10 meters length of a copper wire. This is basically a wire P. You are maintaining this at a potential difference using a key, battery, key, and a rheostat. This is the potentiometer wire of length capital L. Of length capital L. Rheostat is a variable resistor. You change that, the potential difference across PQ will change. Now, your job is to find out potential difference across ED. This is some part of an another circuit. I want to find out the potential difference across this. without taking current from the circuit. Without taking current from the circuit. Connect this to a galvanometer and a jockey. Jockey will be a pen-shaped structure like this with a sharp edge. Jockey will be exactly this way with a sharp edge. Right? Not a point edge. Sharp line. Galvanometer here, this will be a null deflection galvanometer. Null deflection means zero will come at the center. Current flows in one direction, deflection will be on one side. Current flows in the other direction, deflection will be on the other side. So it is a null deflection galvanometer. What is the name of this galvanometer?
Null deflection.
Now this jockey is never left on the wire. What is it that you are measuring? Your requirement is potential difference across AB. This is what you should measure. Is the experiment first of all clear? Aim of the experiment.
Yes, sir.
Now these both points are connected by a small silver wire. A and P are considered to be at the same potential. Now using this jockey, I will pick it up, place it, pick it up, place it, pick it up, place it at different points on the wire, and I will find out null deflection. I will find out that point on the wire on which I should place the jockey, for which the galvanometer will show zero deflection. If the galvanometer shows zero deflection, it's not taking any current from here. It's
Yes.
not taking any current from here. If it is not taking any current from here implies potential. If galvanometer shows no deflection, galvanometer shows no deflection, then potential across AB will be equal to potential across PJ. Potential across AB will be equal to potential across PJ. Do you agree with that?
Yes, sir.
Yes, sir.
If I know potential difference across PQ is directly proportional to the total length, potential difference across PJ will be directly proportional to this length.
Yes, sir.
So when I divide PJ, potential difference small l by capital L into potential difference across PQ. When I divide the two equations, how did you tell me it is directly proportional to the length? Because V equal to IR. Current is the same in both. Resistance के लिए resistivity of whole of this wire is the same. Area of cross section of whole of the wire is the same. So potential is dependent only on length.
Yes.
Yes, sir.
So potential difference across PQ is directly proportional to the length. Potential difference across PJ is directly proportional to the length. It is more like telling you 10 meters potential difference is 10 volts. 1 meter potential difference will be 1 volt. 1 meter potential difference will be 1 volt. Agreed?
Yes, sir.
Now, I want the potential difference across PJ, which will be the potential difference across AB. Small l is measured with a scale placed besides. On the potentiometer, there will be a scale fixed besides. Capital L is also known. If I know the potential difference across PQ, my job is done. In 90% of the problems in your booklet, which we will solve in today's class itself, they didn't place a rheostat. Variable rheostat, variable resistor, they didn't place. What they did is, they placed a resistance of a known value. And they gave you the resistance of PQ. Can you calculate potential difference across PQ? You know this resistance. You know the battery resistance. You know the wire resistance. You can calculate the current and hence potential difference across PQ. Yes or no?
Yes, sir.
Yes, sir.
Yes.
This is the problematic approach given in your booklet. But in practicals, you will not do that. You will keep a rheostat. Why rheostat here? Rheostat is such a unnecessary equipment for me. I don't even know the resistance involved. Variable resistance. The to value, I don't know. It's a headache. I cannot find the potential difference across PQ directly if I have got a rheostat. But yet rheostat is compulsory in the experiment. Why will be explained. First of all, if you have a rheostat here, you don't know this resistance. How will you calculate the potential difference across PQ? That's a headache. You will have to go through an alternative. To complete the experiment, I need the potential difference across PQ. Yes or no?
Yes, sir.
Now we do it using calibration. Calibration. What is this calibration? Take a standard cell with an EMF E0. Its internal resistance will not affect my answer. Don't change anything in the potentiometer, lower part. Don't change the position. Don't change. Do not make any change in the primary circuit. Rheostat, same position. This is the potentiometer wire. This is A, this is B. You connected these both by a small silver wire. This is a standard cell whose EMF is known to me. Now I connect this to the galvanometer and I find the balancing length. What did you say? Balancing length. What do you mean by balancing length? That length for which the galvanometer will show zero difference. Find the balancing length. Internal resistance कुछ भी है मुझे फर्क नहीं पड़ेगा. क्यों? Because you found out the balancing length. No current. No current. So internal resistance of the battery makes no difference for me. They are fooling around when they give you that value. Now, for this length, I know what is the EMF. L0 corresponds to E0. Capital L corresponds to how much? E0 by L0 into capital L will be the potential difference across PQ. L0 corresponds to E0. How? Because galvanometer showed null deflection. You found out that length for which there is null deflection. So L0 corresponds to E0, unitary method. Total L will correspond to how much of a potential difference I know now. Substitute here, will I get the potential difference across PJ? If you get potential difference across PJ, you got potential difference across AB without taking any current from the circuit. Without taking any current from the circuit. So it's an ideal voltmeter. Yes or no?
Yes, sir.
Yes, sir.
Now one question yet remains. आपने बोला था booklet में they gave definite value of resistance for this and this. So directly I can calculate the PQ. My problem was solved here in all the problems of the booklet. Practicals में why do you make me do this with the rheostat? There is a small problem. ध्यान से सुनो. If the potential difference across this is 6 volts, which I don't know, I have to measure, right? Which I don't know. Potential difference across
sir.
this is 6 volts. I don't know, I have to measure. But potential difference across PQ turned out to be 4 volts. I connected these both. Will I get a null deflection on this wire?
No.
I will not get a null deflection. Now, how do you know that above one potential difference is greater? Before you start the experiment, place the jockey at this end and place the jockey at this end. When I place the jockey at this end, deflection should be on one side. When I place the jockey at the other end, deflection should be on the other side. That means somewhere in between I will get a null deflection. Yes or no?
Yes, sir.
Yes, sir.
By chance, if this was 6 volts and this was 4 volts, then when I place the jockey here and here, I'll get deflection on the same side. When I place the jockey here, deflection will come this way. When I place the jockey here, deflection will come this way. It will not go to the other side. That will immediately tell me that this potential difference is greater than the potential difference of PQ.
Yes, sir.
Yes, sir.
Now, how do I increase the potential difference of PQ? Decrease the resistance of the rheostat. current will increase, potential difference will increase. How much do you want me to increase? Keep placing the jockey here and here. First place the jockey here, then place the jockey here. When the deflection comes to the other side, you are safe. Now don't move this and start your experiment. So variable resistance is a necessity for you.
Yes.
You do the practical. Now then students ask me, आपको तो रियोस्टेट का रेजिस्टेंस कम ही करना पड़ेगा कभी भी, ज्यादा तो नहीं करना पड़ेगा, कम ही करना पड़ेगा. Keep it at 0 and do the experiment. Don't keep the rheostat. My problems are solved. Always you will decrease the resistance of the rheostat when this potential difference is greater than this. Agree?
Yes, sir.
Yes, sir.
Remove the rheostat, make it 0 and say, we keep the rheostat because of one reason. Agreed. Experiment will be done if you remove the rheostat, but the student is touching the wire. Excess current should not flow through it. Current should be less. इस वायर पर करंट बहुत कम रखेंगे, right? So initially rheostat resistance ज्यादा रखेंगे and current in this lesser. With lesser current अगर आपका काम हो गया तो I am safe. I will never decrease the rheostat to 0 and increase the current to maximum to measure the potential difference because the student is at a risk of getting shocked. So while doing this experiment, mandatorily we tell the students wear shoes, wear slippers, barefoot not permitted. We do it on a wooden table because there will be some 1 ampere or 2 amperes of current passing through this. I don't want excess current. I want lesser current and the job to be done. That means current should be less, but at the same time, potential difference across this should be greater than the potential difference across it. Hence, rheostat usage is mandate. Before I start the experiment, I will keep the rheostat at a very large value and very little current in it because precaution of safeguarding the student is also an essential necessity. Is this clear?
Yes, sir.
Yes, sir.
Yes, sir.
Take this down till here. In your practical exams, generally this is the trend followed. Every board follows this. 2 batches के बाद third batch the practical will change sequence. Same practicals will not be given for all the batches. Right? When in 12th I took my practical examination, first batch when they came out, we went and asked them what all experiments did you get. We took our practical examination at a time in the syllabus when we had both 11th and 12th together. We used to take our boards with both 11th and 12th syllabus. So practicals may be 11th and 12th, total of 38 experiments if I'm right. So going through all 38 before the practical exam was a huge hectic task. The first batch when it came out, we went and asked what all practicals are being asked. They named 5 practicals: simple pendulum, vernier caliper, screw gauge, calorimetry per एक, and optical bench का एक. So now all our focus now from 38 came down to these 5 experiments. Second batch also we went and asked. They told the same 5 experiments. So now I was confident that these are the 5: screw gauge, vernier caliper, resonance tube apparatus, optical bench and calorimetry, simple pendulum. So pura attention the day before the exam, mine was only on these 6 experiments. I was in the third batch. I went, you know the procedure. There will be question papers with the aim of the experiment written and kept inverted. You'll have to pick up one, whichever you get, you should do. If you change your practical, you have a provision to change the practical, but 5 marks will be deducted. I picked up and I was shocked. For the past 1 day, mentally, I was prepared with vernier caliper, screw gauge, resonance tube apparatus, simple pendulum and calorimetry and the optical bench. Now, for last 2 days, I have not seen this experiment. And the biggest shock for me was, why me? I should do all the connection circuit now again. I will be the first guy to do in my batch. The shock was so huge that I did not move from there. I stood there. I want something to happen and the experiment to change. How will it change? unless I ask for. The external examiner asked me, do you know how to do this experiment? I said, yes. Then he said, your apparatus is there at that corner of the room, you can start. I was not moving from there. I stood there. I want something to happen, but this experiment should change. I want only those 6 experiments. He again asked me, do you know how to do the experiment? I said, yes. He said, do you want a change in the experiment? I said, no, because if he changes, he'll deduct 5 marks. I want the change without the 5 marks for deduction. He called the others. Now, what hurts you more is, my friends who came and picked up the others, only 2 experiments changed. And I was one of the guys. All the other guys who picked up got screw gauge and vernier caliper, then they peep into my paper and they make a sound. The sympathy which they were showing was further sinking me. No, it took some time for me to come out of the shock. Finally, the external examiner came out. He put his arm around my shoulder. He made me walk all the length of the lab. He took me to this apparatus where all the connecting wires were there, kept. And he said, have you done this experiment previously? I said, yes. He said, do you know how to do the experiment? 3rd time he asked me. I said, yes. Then he said, come on, do it. You will be able to do it. And he just wanted to give me some initial impetus or momentum to start. He was patting my back. He was saying, come on, you can do it. Don't worry. And he showed me this galvanometer and he asked me, come on, tell me what is the name of this. He just wanted to give some momentum to me. Well, I was in such a state of shock that I forgot the name of the galvanometer. Null deflection galvanometer is the name. In that state of shock, I forgot. And I thought, he started my Viva. In Viva, they will ask you 3 questions. He already asked me the first question is my feeling and I couldn't answer it. I further sunk. The state of shock was unbearable for me. Visible shock on my face, my friends were giving a glance at me. I put such a grim face at him, showing him my anger that first of all, I'm in a state of shock. Now you start Viva with me. I put a grim face and I looked at him. He said, okay, cool. I'll come back to you, start connecting the wires. And he started walking back towards his table. Half the length of the room he walked. My friend from the other side, he was murmuring, galvanometer, galvanometer. When the external examiner asked me, I couldn't answer it. The state of shock was so huge that I was telling him, sir, it will show deflection. It will show deflection when current passes. He said, no, the name of this equipment. Null deflection galvanometer. मुझे नहीं आ रहा था. My friend from there was murmuring, null deflection galvanometer, galvanometer, galvanometer. Then immediately I woke up and I turned back to the examiner. I don't want to miss that one question of a Viva. I was under the impression out of the 3 questions, one question he asked and I couldn't answer. I turned back and I shouted at the peak of my voice, sir, it is null deflection galvanometer. He turned back and said, okay, cool, wait, I'll come back. Don't shout the answer. And he left. He didn't come back for the whole of the experiment. He was watching me from the distance, but he didn't come back. I thought I am doomed with the physics practical. Firstly, I couldn't answer the first Viva question. And then after submitting the paper, I was standing there for him to ask the remaining 2 questions. He said, it's okay, you can go. I was so demoralized. Baki dono questions puch lo. Now I'm in a state that I can answer, you're not asking. I thought things went so bad. But actually that practical saved me. Those days, out of 30 marks in practical, nobody was given even 28. Nobody in the batch was given 28. You people, almost all of you get 28 to 30. At times, 26 was the highest. 26 was the highest out of 30. He saw me connecting the wires meticulously. When I completely gave up, I knew the first Viva question has been asked. Now I have to do the experiment. It's a do or die situation. Then I did the experiment and I got 26. It was the highest in the batch. Keep an eye on what the examiner is asking you. Necessarily need not be that every question he asks is a Viva question. It will be a casual question asked. How attentive you are at that particular point does matter. Do the practical sincerely. The examiner, once he glances at you, will know how you're doing the experiment. He need not come and stand beside you and see whole of what you're doing. He glances at you in one go, he will know how you're doing the experiment. Right? Take it down till here. There is the second half for this as well. आप लोगों का practicals होगा भाई साहब. You will have to rush through the practical syllabus somewhere in the month of Jan.
Done, sir.
So, but when we are working with DC circuits, no matter like for 10 amperes also current, we won't get such a big shock, right?
Yeah, it will be mild. You'll just feel a numb feeling there sometimes if it is 10 amperes. But yet, to be on the safe side, we generally keep it less than 5 amperes.
Yes, so then even rubber slippers are not required, right?
To be on the safe side, you'll feel the difference. You'll not be comfortable touching. Not that you'll get a shock, but you will not be comfortable.
Sir, in the calibration, can you repeat how you equated L naught to E naught?
We didn't equate. L naught length corresponds to this potential difference.
Yes, sir.
Length will correspond to how much? Unitary method.
Right, correct, sir.
What makes you say L naught length corresponds to this potential difference? You found out the null deflection point?
Yes, sir.
So in practical application, we need two external circuits, right, for the experiment. One for calibration, one for testing.
This one calibration के लिए this is a standard cell. इस standard cell का significance is that it will maintain a constant EMF.
The standard cell means any cell can be used, right?
No. Standard cell का significance is it maintains constant EMF. We used to use Daniel cell, 1.02 or 1.12 volts का Daniel cell we used to use. It was such a big cell. Now I think things have changed. They give you a standard cell. Any cell means you will have to use a new cell. Pencil also will do, but you will have to use a new cell. Now, actually, this becomes a standard method to compare the EMFs of two batteries. How will you compare the EMF of two batteries? I'll place one battery, find out the balancing length. Place the second battery, find out the balancing length. E1 by E2 is L1 by L2.
Yes, sir.
Is that very standard? Any other procedure, I'll be measuring potential difference across the battery. This is the only procedure where I'll measure the EMF, not the potential difference. You agree with that? What is the difference between potential difference and EMF? Internal resistance. Right? Now I place one battery here, measure the balancing length. This balancing length is corresponding to what? Potential difference of the battery or EMF of the battery?
Potential.
EMF. Because there is no current. You are finding out null deflection. So internal resistance doesn't affect your EMF. So place the second cell and find out the balancing length. E1 by E2 is equal to L1 by L2. Right? This becomes the most authentic way of comparing EMF of two cells.
Sir, why does current become zero for such a part in L0?
You are finding out the balancing length, that length for which galvanometer shows zero deflection.
Yes, sir, but why does it become zero? At a
Potential
particular
differences
length.
are equal. EMF of the cell and the potential difference across this length when they are equal.
Right.
There will be no current flowing. Now the second part of the experiment is internal resistance of a battery. You are interested to find out the internal resistance of a battery using the potentiometer. This is the wire. This is the wire, potentiometer wire. You have a standard cell, key and rheostat. Call this K1, K1 and E1. Now I want the internal resistance of E0. I am interested to calculate the internal resistance of E0, that is R0. Connect a resistance capital R here. This I will connect to a galvanometer and a jockey. This I will connect to a galvanometer and a jockey. And I have a switch here. I will have a switch here. Right? First, I will keep K2 open. When K2 is open, there will be no current in this branch. Do you agree with that?
Yes, sir.
So what will be the potential difference across these 2 points?
E0.
E0. I found out the balancing length that was directly proportional to L. I found out the balancing length. I kept the jockey here, and I found out the null deflection point for the galvanometer. That means potential difference across this and across this will be the same. That's why I found E0 directly proportional to L.
So I'm getting confused. Why do we E0 and not V0? Like,
E0,
why it will be E0 and not V0? Like considering the internal
there is
resistance.
no current in this. How much is the potential drop across R0?
Zero.
So potential difference across this is E0.
Yes, sir.
That potential difference is equal to the potential difference across this.
Understood.
This potential difference is directly proportional to L. This was when key was open. When K2 is closed, what will be the potential difference across AB? VAB is equal to I into R. I into R. I will be E0 by R plus R0 into R dB. Till here, are you clear? Potential difference across AB is I into capital R. Yes or no?
Yes,
Yes, sir.
I is E0 divided by R plus R. Now you find out the balancing length. Potential difference across AB is directly proportional to L0 dash. Now the new balancing length you find out is L0 dash after closing the key K2. That means it will be E0 by R plus R0 into R will be directly proportional to L0 dash. VAB is this quantity. This is directly proportional to L0 dash. Divide both the equations. R plus R0 by R is equal to L naught by L naught dash. Will I get R naught?
Yes, sir.
When K2 is closed, there will be current here. That current will give me a potential difference of I into R across A. That potential difference will be equal across this balancing length L naught dash. Only then I'll get null deflection. So that VAB I substituted here, divided both the equations, I get R naught, which is the internal resistance of the battery. Take it down till here. I'll take a few examples.
So K1 is always closed, right?
This will always be closed. If it is open, there will be no potential drop across the potentiometer wave. There will be no current in it.
Sir, if K1 is open and K2 is closed, we can still find the potential difference across that length, right?
Say that again.
So if K1 is open and K2 is closed, then we can still find the potential difference across that particular length of the potentiometer, right?
Oh, there will be no current in this. When K1 is open, there is no current in the potentiometer where there is no potential difference. क्या calculate करूँ? Potentiometer wire पर potential difference 0 है. Current is 0 in this. Potential difference है ही नहीं.
Right, sir. So actually, I was referring to a circuit that the jockey would make with the above circuit with the potentiometer. Like we've connected the galvanometer to the jockey, so there's a circuit.
Jockey is never left on the potentiometer wire. There, jockey always there's a gap. You never leave it on the potentiometer wire. You place it, pick it up, place it, pick it up. If you're not doing the experiment, you'll keep it in the stand.
Okay, sir, got it. I understood.
That's it.
Question number 88. Please read the question. I will discuss this. Or okay, attempt the question, not an issue. Question number 88. Are you able to see that?
Yes, sir.
Yes, sir.
So,
What we drew on the lower part, they drew on the upper part, and vice versa. We drew primary circuit on the lower part, they drew primary circuit on the upper part. Solve the 88. I'll just be back in a minute.
done, sir.
Now listen. I'll solve this. This is 6 volts. This is the potentiometer wire. Right? Uniform wire of length 1 meter. Right? Positive terminal of another battery of EMF 4 ohms and an internal resistance 4 volts and internal resistance and an ammeter. Ammeter shows no deflection when the jockey touches the wire at the point C. This is A, this is B. Right? Now listen. All of the 6 volts will appear across this. He did not give you any resistance for this. So potential difference across AB is how much? 6 volts. I want potential difference across AC will be how much? As simple as it. Hey, have I gone wrong with the interpretation? Uniform wire of length, positive terminal of another battery joined at a S1. The ammeter, yeah, potential difference across AC will be 4 volts. Potential difference across AC will be 4 volts. This internal resistance doesn't affect my problem.
Yes, sir.
Right? So what is the length? 1 meter, 6 volts corresponds to 1 meter. 4 volts corresponds to how much? Unitary method, 1 by 6 into 4. The answer will be 2 by 3 meters. As simple as it. Is that clear?
Yes, sir.
Yes, sir.
Yes, sir.
If by chance they gave resistance to this wire, then potential difference across AB would not be 6. You will calculate the current. I into R will be the potential difference. Agreed?
Yes, sir.
Yes, sir.
Yes, sir.
Will you solve the next?
Yes,
Yes.
sir.
You have 3 problems to solve. 90, 91, 92. 90, 91, 92. I am waiting for you people. You are able to see the screen.
Yes, sir.
90, 91, 92. All 3% visible on the board. On the screen rather.
Done, sir.
Can I stop the screen share?
1 second, sir. Just 1 minute.
Sir, can you tell the answers?
90, 91, 92.
So BBB.
Exercise 1. 90 is B, 91 is B, 92 is B. All three are B.
Yes, sir.
Now look at the 90th question. He's asking potential gradient. That means potential difference by length. A potentiometer wire has a length of 10 meters and resistance of 10 ohms. Potentiometer wire has a length of 10 meters and resistance of 10 ohms. Connected to a battery of EMF 11 volts and an internal resistance of 1. Right? So what will be the current in this? Current will be 11 divided by 11, 1 ampere. So potential difference across AB, VAB is I into 10. This will be 10 volts. So potential gradient VAB by length is 10 volts by 10 meters. This is 1 volt per meter. Something very silly, as just to make sure that you get accustomed to the word potential gradient. 90. Can I rub the board?
Yes, sir.
91st. Length of a potentiometer wire is L. This is L. This is the length of the potentiometer wire AB. Cell of EMF E is balanced by a length L by 3 from the positive end. If the length of the wire is increased by L by 2, increased by L by 2, at what length will the same cell have a balancing length? An EMF of E is directly proportional to L by 3. First info given. Right? Now, if the length of the wire is increased by L by 2, it is increased by L by 2. Now, what is the total length? 3L by 2. Right? First of all, potential difference across AB would have been how much? L by 3 E into VAB. What am I doing? No, sorry. L by 3 length corresponds to E. L corresponds to how much? E by L by 2 by L, this is 2. Why did I take L by 2? L by 3 no. L by 3. L by 3. 3E. So potential difference across this was 3E. First point. Is that clear?
Yes,
Say
sir.
something. Now potential difference across 3L by 2. 3L by 2 will correspond to how much? Should not be difficult. And what did they ask? Maybe I skipped the question. At what distance will the same cell have a balancing point? Now for 3L by 2, I know. At what distance will I have E? For 3L by 2, how much will I get? How much am I getting for 3L by 2?
9E by 2.
How much?
9E by 2.
9E by
2.
2. Now my requirement is E 9E by 2. 9E by 2 is across 3L by 2. E will be across how much? Unitary method is asking you where will I have the balancing length for the same cell? Cheap tricks, well played. Can I rub the board?
Excuse me, sir. So I had solved this using a rather different method. So I took E and L corresponds to E and L by 3 corresponds to E naught. And so I found the ratio E like being the two different E's. And so that I found to be 1 by 3. And then I just changed the length so that 3L by 2 is equal to E and then X is equal to E naught. And I took the ratios of E and E naught to be constant. Am I permitted to do that? Because I'm getting the right answer.
No big deal, no, yeah, it's the same thing. It's the same thing. You change the symbol from E to a different value. Nothing wrong. Now 92 is a genuine potentiometer question. 92. ध्यान से देखिए. You have a battery, internal resistance are connected to a potentiometer wire like this. This is P2. This is the potentiometer wire. Now he says this is E by 2 2R galvanometer jockey. Now this length is L. This resistance is 9R. So what will be the current in this? E divided by 10R. Potential difference across PQ is potential difference E divided by 10R into 9R. 9E by 10 is the potential difference across PQ maintained by this battery. Till here, is it clear?
Yes, sir.
How did you find out that I into R? How did you find out that I into R? Now you are asking me where will I get balancing point? See, this resistance is unnecessarily given to you to confuse you people.
Yes, sir.
This resistance is unnecessarily given to you people to confuse you. I for Ln it is 9E by 10. Right? For what length will it be? 9E by 10 corresponds to L length. E by 2 corresponds to how much length? Unitary method. Can I rub the board? Ninety-third problem. 93rd problem. Think carefully and solve the problem.
Done, sir.
Sir, 1 minute.
Can I stop the screen share?
Yes, sir.
Yes.
What is the answer?
None of this is the answer.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
So I'm getting A.
People who are getting 2 meters fell for the track which they wanted you to fall for. This is 5 meters and this is 0.5 ohms. And this is 4.5 ohms. Are you able to see the board?
Yes.
Now observe the polarity carefully. First of all, if I take this to be potential at B to be 0, what will be the potential at A? What is the current in this basically? Current I am getting 1 ampere.
Yes,
So
sir.
this will be 4.5 volts. This will be higher, this will be lower. Yes or no?
Yes, sir.
Yes, sir.
Now see the polarity of this. This is 3-volt battery. This is 4.5. The jockey's tip will have 4.5 plus 3, 7.5 volts. Will you find a point on the wire which will be at 7.5 volts?
No.
No.
They played with the polarity of the battery. If the battery polarity would have been this way, then answer is A.
So then we needed 1.5 volt, right?
What?
If it was reversed polarity, then we needed 1.5 volt.
Yes, sir.
Why will get 1.5?
On the jockey.
Jockey's tip will be 1.5. If the battery was reversed, this was 4.5, then this would have been 1.5. Quite obviously, you will find out the answer will be 2 meters.
Yes.
So whenever you are solving the questions on potentiometer, always make sure that the polarities are the same. Is that clear?
Yes, sir.
Yes, sir.
Just a minute, can I show the board? Done.
Meter bridge is a beach stone bridge. This is meter bridge, as the name goes, length of this wire will be 1 meter. As the name goes, the length of the wire is 1 meter. You are maintaining that as a potential difference. You have this as an unknown resistance and this is a resistance box. Resistance box कभी देखा है आप लोगों ने?
Yes, sir.
Resistance box पे plug in होता है. You plug in and you get the resistance. In
Yes,
this you
sir.
can adjust the resistance. Keep some value of the resistance. This is the unknown resistance which you have to find out. So use the jockey to find out a null deflection. If this length is L1, this length is L2. Simplest experiment you can think of. X by L1 is a resistance box value by L2. You get the value of X. Find X. क्या बोल रहे हो यार? यहाँ resistance लिया आपने, यहाँ length लिया आपने. Multiply rho L by A, rho L by A. Rho by A got cancelled. X by L1 is resistance box value by L. This by this is equal to this by this. You will get null deflection.
Yes.
Which principle is that?
Wheatstone.
Wheatstone bridge.
So can you please repeat the logic for this?
Wheatstone bridge. This by this is equal to this by this. Null deflection. No current in this branch.
Yes, sir.
Homework. HCV 1 to 56 current electricity. Current electricity कब तक खत्म करोगे?
So capacitors discussion was pending, right? Booklet.
Capacitors, booklet, pending. Yes. वो कब रखे?
Friday.
When do you want me to keep the doubt lecture?
So Friday.
Friday? I am okay with it. But you have additional homework. One more lecture in current electricity. Booklet से भी doubts आना. Booklet से भी exercise homework आ जाए. तो थोड़ा speed up करो. As you people know, we covered much of current electricity in the previous chapter. So current electricity बहुत जल्दी हो जाएगा.
So until when?
On Wednesday we can keep it 2 hours without lecture.
So
Wednesday.
Wednesday we already have doubt lectures.
Then you'll not be able to. Then Friday.
Yes, sir.
Okay, listen. Friday we'll keep a doubt lecture. And only after completing doubts of current electricity we'll start magnetism. So regular lecture भी एक lecture doubt lecture में convert कर दें.
Okay, sir.
Is that clear?
Yes, sir.
Yes, sir.
Sir, in what order will you be discussing?
Pardon?
Sir, in what order will you be discussing?
I don't know. You people decide.
The capacitors booklet, then current electricity HCV, then current electricity booklet.
Sir, it's
Right.
assignment-
Capacitors booklet.
assignment pending, right?
Pardon?
The capacitors assignment.
Capacitors assignment discussion नहीं हुआ है क्या?
Last time.
Last time किया था शायद.
Okay, sir.
अगर नहीं हुआ तो वो पहले कर देंगे capacitors booklet से पहले.
And
Right.
certain when will they finish this track?
It should be over. Magnetism एक बार शुरू होगा तो 1.5 month में हो जाएगा. अब now the pressure is on you people, not on me. Current electricity आपको खत्म करना, it will not be easy. 98 problems सिर्फ booklet exercise 1 का है current electricity. Right?
Yes, sir.
Speed it up. See you people in the next class. Good day. Bye.
Bye, sir.
Thank you.
Thank you, sir.